Okay, so let's do a step function first. So if I give you, it'll change all the time. So h of x equals this greatest integer of. So remember the brackets with the second line. That's what that means, greatest integer of. And then I'm going to put, change that's what we do all the time. How about 2x minus 3, and then close the bracket with the double line. So as a reminder, and for Jace, because he wasn't here, right? How do we do this? Once we have an equation, what's the first thing we always do? Make our table. Now our table is a little funky, isn't it? We need a lot of room for our x's, not a lot of room for our y's. How are our x's always set up, no matter what problem we are doing? -1. Less than or equal to. Yep. X less than 0. Always do equal to on the left, just equals on the less than on the right. And we're going to do the same process. You always do between numbers. So -1 to 0, then 0 to 1. Same inequality, same x's in the middle. Only thing that's going to change is the numbers. Then 1 to 2, and 2 to 3. Now, how do we find our answers for our y's? Because we got a lot of going on in that x side of the table. Always plug in the left number. So -1, plug -1 in here. -2 times -1, and then -3 is what? Correct. Plug 0 in. -3, yep, -3. Plug 1 in. -1. Plug 2 in. +1. Now, with this one, it helps just to make your table with the numbers you have, right? This is the one time that those pre-made graphs are not always helpful because you can't really read them. You can use them, sure, but you can't really read them. I'm going to go down so I have room. My x's. Oh, I did this wrong already. Oh, man. And it doesn't erase well. Okay. X's. Y's. +1 for y. 1, 2, 3, 4. Oh, man. 5. I'm all kinds of messed up today. I just got my hands clean, too. Be thankful you have erasers. Okay. All of these pictures always look like steps. So this image right here makes a closed dot on the left and open down the right. And when they're in the same line, they connect to make a line, right? So -1 goes to -5, closed dot. 0, because they're on the same spot, 0 also goes to -5, open dot. And since they're on the same line for x, you connect them. Then 0, -3. So plotting points, if you can't do that, we're already lost. 1, -3, open dot, connect. 1, -1. Oh, that's ugly. Other than mine's a little ugly, did we get the same picture? Does that make sense, Jace? Kind of. So this always stays the same. This never changes. You always use these. All you do is just you always use the left number when you plug it in. You just plug it in. These brackets really mean nothing. Those brackets mean this is how the table's set up. So like after you have this set up, those brackets mean nothing. It's like a linear equation when you plug the number in. Okay? And then all you have to remember is a step function, which is this guy right here. Always looks, it doesn't look like if I had a little person, he looks like he could climb these steps. Okay? And then all you have to remember is this and what number to plug in. And if they're here together, since this is all here together, that's why they're connected. If they're together in the table, they need to be together in the picture. Okay? And then, so domain. We picked any numbers we want. We had specific numbers, but do any of our numbers change? Domain for this is always, because we're going from one to another, it's all connected, even though they're spaces. It's always all real numbers. You can either write all real numbers, right? Or you can do, I put 2 L's. There you go. Or you can put double bar R. That's the symbol for all real numbers. It's up to you. I literally put 2 bars and then make an R out of it. Now your range. What's our range going to be? These are all whole numbers, but what kind of whole numbers are they? They're odd numbers. So we're going to say all odd integers. And if we don't want to write the word for integers, what's the symbol for integers? A double middle line Z. That's the ugliest one I've drawn yet. It's a Z with an extra line in the middle. It's just like a thick base in the center. Why are we always using whole numbers again? Maybe this will help Jace out. Why again are we using whole numbers? What does this mean again? If we have these numbers. Let's start with the positive one. 6.9. This is the greatest integer of 6.9. What's the greatest integer, Cass, of 6.9? 6. Decimals are not allowed in step functions, so you always round down because it's what's the biggest number that made that one? What's the biggest whole number that makes 6.9? Right? 7, you can't round up because it's saying what's the biggest whole number that was in it already. That's why it's 6. Does that make sense? Okay. With negatives, it's the same thing. It just feels wrong because it's backwards. Because all my 0 answers, anything between 0 and -1, our answer went to -1. So with negatives, you're basically rounding down. So -3.8, Jace, what do you think the answer is going to be? Correct. That's why this is set up the way it is. Because we're doing everything between those numbers all get the same answer. That's why it looks the way it does. Does that make more sense? Okay. Now, piecewise function. Changing colors. As long as it's not blue, I do not care. I'm just going to flip this because we all know there's not enough room. Now, again, it can be any variable we want. F of x equals, always put a bracket big enough for 2 lines. Just one bracket vertically for 2 lines. Then we're going to write 2 expressions on it. Today, I'm feeling -3x minus 2. That's my first expression. Leave a little space. Then write the word if. Then I'm going to write x is greater than -2. Next line right underneath, we're going to write -x plus 1. That's my expression. If, these are my limitations, x is less than or equal to -2. So these are your expressions that you're going to plug stuff into. These guys basically are your domain. If these numbers are the same, it'll always be all real numbers. So if you see -2 twice, it'll always be all real numbers. If your numbers are different, that's when you're going to have spaces in your domain, just like the range does. So this one, again, the table is really important. This one's set up like a normal table, though. You don't have to make extra space on one side. Just making a normal table. Now you see how, Jace, these are two separate things, like there's a top one and a bottom one? So it says x is greater than -2. So we have to pick numbers that follow this rule, because only those numbers can fit with this equation, because that's why they're separate. This equation's only for those numbers. This equation's only for these numbers. Okay? Every time we do this, every time you look at this guy, you always pick the number that's there. So it says x is greater than -2. Well, you have to pick -2, because that's your starting and stopping point. And then you have to pick a number that follows this rule. So, Jace, what's a number that's greater than -2? Yep, -1. We always pick the one that's next to it. You always need two numbers for that. Once I have two numbers, I always like to draw the line so I know those numbers are for the top. I'm writing really big because my marker is broken. Now we're going to do the same thing down here. We have to pick this number, so we're going to write -2 again. Okay, now AJ, give me a number that follows this inequality rule. X is less than or equal to -2. -3. Okay, now you remember when we did step functions, one of them was open circles and one of them was closed? When it says equal to, that means we include it, so it's closed. If it just says greater than or just less than, it's open. So we need to mark here to help us figure out what our picture is going to look like. So in the top one, is this 2 have an open or closed circle based on this inequality? Open. Now, Jace picked -1. Could we pick any number we wanted? So what do we do to represent that we could pick any number greater than that? We're drawing an arrow towards that to say, hey, we picked anything we wanted. That means our arrow is going to go towards that way. Our picture is going to go towards that number. Those are our two numbers. They both have a picture next to it. We're done. Now we're going to come down here. This -2, open or closed circle? Closed, because it's got the equal to sign. And again, AJ picked -3, which is what I would have picked, right? But could we have picked -52 if we really wanted to? That'd be silly, but yes. So again, we're going to draw an arrow towards it. It helps us think about what our picture is going to be. Now we're just doing the basic math. These top numbers, one at a time, plug them into your equation. Take -2, plug it in for x. -3 times 2 minus 2. Braden, what do you as an answer? Do we all get 4? Okay. -1. Take that. Since it's on the top, we're plugging into the top because that's where we picked those numbers for. Plug -1 in the top. Chloe, what'd you get? +1? We agree. Okay. Now that we're at our bottom numbers, we're going to plug our bottom numbers into the bottom. That -x is going to make a difference because when they're both negative, what happens when you plug a negative with a negative in front of it? It becomes a positive. So all our numbers are going to be positive for these ones. That's nice. Ty, what's my answer when x is -2? 3. Isaiah, what's my answer when x is -3? 4. Some kind of sense. Yes. Okay. Now the picture. You just use a normal graph for this. I always just go as big as it is. So my biggest number is 4. I'm going to go 4 every single way. Again, you can use the graphs I give you or the ones that are up there to offer. Never give myself enough room. Never, ever, ever. Ooh, wakey, wakey. Okay. When you graph them, always just do this group together, make sure it looks fine, and then this group together. So this guy, always plot the circled part first. So -2, 4, you're going to plot an open circle on it. So -2, 4, open circle. Now again, this one could have been anything we want. So we're going to make a regular dot when we plot the second one that has arrow. -1, 1. -1, 1. That's a regular dot. So you have 2 points for that thing. When you finish the picture, you have to go from the open circle towards the second one and draw an arrow, saying it's going that way. Until I see my other picture, I don't want to extend it because I don't want to mess it up. So now we do the second one. -2, 3. -2, 3. It's right under it. Then -3, 4. This one's going this way. So now I can say, oh, well, this is going this way. I can extend that one if I want. This one to draw this arrow. They're drawn like that. Even though that one you can't really see the arrow. There you go. Now your domain. Since your numbers are the same, your answer will always be all real numbers or double bar R, which means the same thing. Remember, if these numbers are different, you're going to have to look at it the way you look at the range. Now this time, Braden, think about it. That's only for step functions. You don't use integers in this one. It is all something. It is all real numbers. This one, right? These are on top of each other. Remember what I do? Turn it sideways. Because if you want to look at your y's, it helps. Is there any space between these two dots where there's no lines? Where lines are not filling the space between them? No. So this one covers all this space. That line keeps going, right? So you still see space. That means that one comes over. So that means my hands are covering the whole graph. My hands are covering the whole graph. Does that mean every number is being used? So that means it's going to be all real numbers. That is the hardest part, and we'll do it more and practice it. Okay, I want, just make sure you take a marker with you. I want, let's see, I'm going to pick Braden, and I'm going to pick Lila. You're both going to have to share the same board, though. You're gonna have two different problems. You are going, if you were in the peanut gallery, that means you out here not wearing your mask. I was just picking on Cass, you know. You need to do the type of problem that is harder for you. One of them's going to get a step function, one of them's going to get a piecewise function. If you are good at the step functions, not so good at the piecewise, do that. When in doubt, at least try to do the domain and range of both. Okay? Are we ready, ladies and gentlemen? Okay. Lila, I'll give you yours first. Lila, your function, I picked you both because you both have some height to you because you're going to need the entire board. So I would start at the top and work your way down because you're going to have to do it, make the table and the graph. So you're going to need your space. And you have to share a board. So just putting that out there. Lila, your function is f of x equals the greatest integer of the double bracket 1x minus 5. That's it. Closer. Yeah, one of those is way thicker than the other. Brayden! What did I give you for homework? Brayden, I'm going to give you f of x equals, obviously. Oh, man. And he gave him a blue marker. Okay, f of x equals 1 bracket. Oh, there you go. Now we can see it. Top one is 2x minus 1 if x is greater than negative 1. The bottom one is, your function is negative x. That's it. Then if, we didn't line up as this, x is less than or equal to negative 1. There you go, sir. I'll write them down for my peeps at home. Just turn that off. Come on, for just a minute. Come on. Will you just get your leg together? Move this over here. Okay, still recording. Thank you. Okay, gonna do this together. Your brackets are getting really good, and your even double bar R is getting real good. You just gotta think about that range. Where's the lowest point on your graph? Everything's above it. Correct, sir. I think you got them backward. I can't even read that. What does your domain and range say? I think you got them backwards, though. I'm pretty sure your domain is all real numbers and your range is integers. Whoops. Your domain is always all real numbers. That never changes in your step function. If it's anything other than that, you did it wrong. Remember, domain is your X, range is your Y. They're not bad, although I can't really see it. I wrote tiny, like Braden used all his space. You used like a third of your space. So no one could see it but Cass. Remember, we all want to be able to read it. Okay, so for your homework, for the first set, those 4 problems, 2 of them are step functions, 2 of them are absolute value, not absolute value, 2 of them are piecewise functions. Now, what we're going to do today and continue tomorrow for practice is absolute value functions, which is what we're going to do now. Which there's 2 good ways to do this. Either you use the table all the time, or you can do this great thing of use the transformations that I taught you. It helps you figure out if you did it right. It'll come back up. Okay, so this literally is the last section. It is 3.8. And it is literally called absolute value functions. If you did not know this, an absolute value function makes the shape of a V. Think value for V. That's what it looks like. Okay, now, how you know what to do. The original equation with all of the letters that represent numbers, basically the transformations, looks like this. F of x equals, because it's a function, A, and then absolute value line, remember, is a straight up and down line. And then x minus h, close your absolute value. And then plus k. You remember when we talked about absolute values and transformations. Absolute values make something positive. That's why absolute values almost always face up unless there's a negative on the outside. Also, you remember all our transformations, k moves something up and down. This h is backwards, still the same thing, it moves something left or right. Still the same thought process. Now the cool thing is that opposite of h, so negative h, comma k, the point is actually your vertex, aka the point in the V. So you make everything surrounded by that. You base everything off of whatever that is. Right, so if vertex, literally, it's a V shape, that guy right there is your vertex. Right, it's the point in the middle. With this one, your domain will always be, again, all real numbers. Okay, and then your range is one of 2 things. If your picture is facing up, It is y is greater than or equal to whatever k is. That would be your range because the picture is above. And if your picture is facing down, so it's a sad V, what do you think your range is going to be? Nope. Y is less than or equal to whatever k is because it starts at that point and goes down. So the only thing that changes is the inequality sign. It's either greater than that or less than that. Okay? So that's the only two options. And then obviously k is a number. We just don't know it yet. Just depends on what's going on. There's no number here. If it just says absolute value 3x, what number's outside if there's no number there? What number represents nothing? 0, right? Just like a linear equation. If you have, like your bell ringer, if you just had y equals 5x, your y-intercept would be 0 if there was nothing plus anything there. Okay? So, for example, f of x equals absolute value of x and then plus 2. Every single time, you should always just decide, tell me what h is and what k is, because those are important things. Since h is not there, what is h? 0. That's easy. What's k? 2. 2. It's whatever this is. This helps you set up your table if you would like to make your table, which is probably the best option. Tables for all. Now, with an absolute value, since this is your V, your vertex, right? This is in the middle, isn't it? Because then you have some of it going to the left and some of it going to the right. So when you put your vertex in the middle, you're going to literally write it in the middle. So leave space above and below, 0, 2, 0, comma 2, like the order pair. Then from this x value, because this value is going to change, h is going to change every single time, right? You need to pick x values less than it and greater than it. You need at least, you have to always have odd number of points. 3 is really fine as long as you can still make a v. So what's a number less than 0? -1. What's a number greater than 0? 1. You're going to see something real cool. Which one do you think is easier to plug in, a positive number or a negative number? A positive number, right? Because absolute values, we like positive, right? Take 1. Plug it in there. What's the absolute value of 1? 1 plus 2. My answer is 3. Yeah? Plug in -1 plus 2. What do you notice? They're the same answer. With absolute values, if the x distance is the same, you see how these are 1 away? The y values will always be the same answer. So you only ever have to plug in one of them. If you picked 5 points, like if I picked -2 and +2, I'd only have to plug in 2. If I plug 2 in, what do I get? Take a wild guess on what -2's answer is going to be. 4. That's why it makes a V, because they are equal on the y's. So when you graph it, right, this is, the y's are all positive, which is nice for now, right? So I'm just going to put 2 out both ways. Always plot your vertex first. 0, 2, 1, 2, 3, 4. So 0, 2, just a normal point. I always just make it big so I can see it and you can see it. Plot all your points. Just don't connect them. Just look at your points. -1, 3, 1, 3. If I'm feeling real feisty, even though I can't draw, I'm going to do 2 and -2. What do you notice? It makes a V. When you draw the picture, start from the center each time. Go to the left, make an arrow. Go to the right, make an arrow. Every single time, it is literally that easy. Right? Domain is always what? All real numbers. So basically what you're saying is, for the most part, piecewise functions are the hardest functions. Range. Since this one's facing up, what is your range going to be, Michelle? I said Michelle. I know you got excited, but I said Michelle. Look right up here. It'll tell you the answer. Okay? Or equal to. Yep. The only difference is the book, since it's a function, instead of writing y, it writes f of x. Aren't they the same thing? They're the same thing, so it's okay. Does that make sense? Is that pretty easy? The hardest part is h. When h, because h is opposite. Let me give you one that's got some, some stuff going on in it, okay? F of x equals, probably depending on how long this is, our last one. How about, how about a 3 on the outside, then your absolute value, and then x minus 2, close your absolute value, and then minus 3. I made that up. A lot going on. The important part is either write h and k separate or write it as an ordered pair. It does not matter to me. Remember, h is first. Remember, it's opposite of h, comma k. So what is my vertex pair? Look at what it looks like. So what's my order pair for? It already says minus 2. So now it's 2, negative 3. So opposite means the opposite sign that you see there. So if it says minus 2, it's actually positive 2. If it says plus 2, it's really negative 2. So that's the hardest part, because if you mess up the vertex, did you literally mess up everything else? So a good way to check if you're doing something right, if you mess up your H, is check your table when you plug numbers in, because, well, that's the worst line I've ever drawn. Your numbers will not be equal here if your vertex is wrong. So you can always check your math that way. If you check the numbers right outside of it and these y values are not the same, your h value is wrong. Okay, let's do 5 points. Let's get her out. Okay, 2 comma negative 3. So what are my x values going to be? 2's in the middle. What goes above it? 1, then what? Okay, then 0. Underneath it. Then easy. Easy, easy. Do the math. It doesn't matter which ones. In this case, because you have to multiply by a lot, subtract a lot, it might be easier to use the smaller numbers. It might be easier to use bigger numbers, right? It's up to you. I'm going to type in 0 and 1. Remember, you have to subtract on the side, make the absolute value, then multiply 3, then subtract. You have to use your order of operations correctly. So if you take 0 and plug it in, 0 minus 2 is negative 2. Absolute value negative 2 is just 2. 2 times 3 is 6. Minus 3 is 3. So make sure you keep your order of operations correctly. Yes. Yes. Absolute values and greatest integer functions, you have to treat them like they're parentheses. But in this case, you can remember you should still simplify the inside before you multiply. Do not distribute the 3. So then plug in 1. 1 minus 2 is negative 1. That's positive 1. 1 times 3 is 3 minus 3. Make sure you did it right. Maybe check only one of these. Oh, yep, that's right. We good. All positive except for that one number. That means I can go like this and like this because all my x's are super positive. Always plot your y and your vertex first because it helps you remember where you're going. 'Cause if not, people think they're drawing it wrong and then they erase it and they're doing it wrong. That's a big guy. It would help if I could draw a straight line. Is your picture looking like mine? Minus the lines and the straightness. Because I don't know what happened right there, but I got a little sketchy. Ty, what's my domain going to be? All real numbers. Dana, I haven't talked to you today. What's my range going to be? Bonus question. What is the only thing that's going to change my range? I want a specific variable. I'm looking at the wrong paper. I want a specific variable. Think about the original problem. What is the only thing that's going to change my picture going from this to this? You have to remember transformations. Raise your hand. Don't just shout it out. This is not PE class. You don't just scream for no reason. Anybody have an idea? Have a thoughtful, have a well played out idea. Don't just kind of like blur words at me. Think about your transformations. Think about where those transformations are that do certain things. Anybody? Bueller? No? Chloe? What's the only letter we didn't really use? A, right? When we multiply, what transformation is that? What transformation is that? H moves left and right. That's a translation. K is a translation. Huh? We're looking for a reflection. A is actually like a dilation. But reflections have what in them? How do you know something's a reflection in your transformations? This is on your test, so this is important to know. What symbol is in your equation to know it's a reflection? A negative sign. Where's the two places it could be? Usually it's parentheses instead of absolute values. It can be either in front of it or in it. What happens to a negative when it's inside of an absolute value? It's gone, right? So where does a negative have to be to change my picture? In front. Anytime you have a negative out here with A, it'll flip it to look like this. Oh man, we got a lot of reviewing to do. Transformation. Other than that is absolute values. Not so bad. Pretty easy. Easier than all the others. Even easier than step functions. Step functions, as long as you remember what the table looks like, you golden, right? Jace just got the horrible experience of having to do it all in one day.